The atom is the smallest thing ever discovered in history. An atom is said to be in everything. It's in things from desks to tables to yourself. Over time, it has developed into many models to explain its uniqueness. Many scientists have contributed to the development of the atomic theory. Today, we will be discovering what led to the development of the atomic theory. It all started when a Greek philosopher by the name of Democritus developed the idea that everything had to be made of one type of particle. He called the particle atoms. He thought of it as that everything had atoms in it no matter the size or weight of the object, whether it was living or non-living. Think of it as a rock and a bigger rock. Both rocks contain atoms no matter the size or the weight. Then came John Dalton, who proposed that atoms had different sizes and mass depending on the element. He proposed that all matter is taken up by atoms. He said that all atoms could not be created, destroyed, nor subdivided. He also said that atoms of given elements are identical in size and mass. His model looked a little like this. He had the idea that although atoms could be made of different sizes and elements, they could still be merged to create ratios with an uneven whole number. Think of water and how water is a compound of two elements, two hydrogen atoms and one oxygen atom. Then came Joseph John Thompson, who in 1897 made the groundbreaking discovery of an electron. His idea was that atoms were positively charged and contained small negatively charged electrons. A common comparison is a chocolate chip cookie, or in this case, a chocolate muffin. It is packed, made of flour, but inside with the little speckles of chocolate chip. The chocolate chips are represented as electrons, while the flour or dough are represented as the overall atom. After his discovery, one of his students, Ernest Ford, did an experiment where he shot positively charged particles to a sheet of gold. When he did this, the particles, instead of going through the sheet all the time, only sometimes got through the sheet, where sometimes the positively charged particles would bounce back. He concluded that the center of the atom where all the mass was located and where all the particles were bouncing back off was called the nucleus, and that there were sometimes electrons that would circle around the nucleus. He also concluded that the nucleus was dense and positively charged. This means that there are space between the molecules or the atoms. His experiment is often compared to a fishing net where some fish can get out, but most are kept in. In 1914, there was an expansion to the model by Niels Bohr, who was also a student of Thompson. He concluded that electrons orbit the nucleus, but were never in the same space, but can jump to different spaces. This can be compared to the solar system. The sun is orbited by planets, but the planets never cross paths, but they do move. It is also discovered that electrons stimulously moved like waves through many experiments. Werner Heisenberg came up with the conclusion that electrons could not be exactly pinpointed, but could be predicted, therefore the waves. This led to the current, most updated atomic quantum model, which is still currently used today. This model shows that the nucleus is in the middle, but the electrons are in randomized places but are still orbiting. Throughout history, there were many contributions made to discover the atom and come up with an accurate model of the atom. We have made much progress, and there is more progress to come.